I'm Joshua Herman, the lead developer for CoinSailor. I don't have an email there, but this is my corporate email. First is, who am I? This guy is Donald Knuth. I helped him out with his presentation. It was funny. He was at FOSS, and the greatest thing I ever did for that was to help him play his presentation. Because his presentation was a PDF, because obviously he's going to do PDFs, and for some reason Adobe Acrobat was auto-incrementing slides. So after the master's or PhD student attempted to fix it, I fixed it by just changing the preview. I'm the lead developer for CoinSailor. It's a gamified education platform and also a matching tool for cryptocurrencies and tokens and so forth. But let's get back on topic. The value. So this is my very fast and half-done way of computing pi using Django and Ethereum. You might notice that there's no point here. We'll get into that later. But first, what's a blockchain? People tell you it's a database, or it's something else, or it's some kind of financial institution, but it's not. It's more like a log-structured database like that everybody can write to. It's not just a database, but it also represents an attack surface because now all of your code basically has a bug bounty. A lot of people try to explain it as chains and other thing, and I like to explain it as like Twitter, except everybody who tweets to you is on one Twitter account, and everybody hosts everybody else's Twitter account. So to be more specific, it's a peer-to-peer distributed ledger is a blockchain. The ledger is the entries in a database, which is a log-structured database. It's peer-to-peer because you can download events from anyone, and everybody can participate with approximately the same access as long as you have an identity on the blockchain, which is your wallet, and money or something invested in it if there is a proof of work. But that's beyond the scope of the talk. Why they call it a chain is that each point or each tweet has a pointer to the next one, unless you're at the end. And as I reiterated already, everybody has a copy of the blockchain, and that's the peer-to-peer aspect. And if it's a public blockchain, everybody can see every operation. Versus then there's two other kinds, which is private and obscured. Private was a Hyperledger system, which I have a certification for because it helps get you clients. And also a permissioned or obfuscated one would be like Monero, like another chain where the transactions are intentionally hidden off-chain or some other method. And let's go look at a nonce, which is a piece of the blockchain where this part, it's the successful output of the hash function when mining. And the hash function can vary, but mainly we want to know is it'll compute this, like the zeros, and makes it hard for it because of you're doing the problem of hash inversion. And also the rough difficulty, which is like a rough estimate of how difficult it is to mine that block, and a timestamp because you need some kind of ordering of the blockchain. And basically, in any blockchain, the highest number wins, meaning the highest timestamp wins. And all of these are in hexadecimal numbers. Now, what Ethereum brings to the table is a scripting language or a stored procedure, if you're familiar with regular databases, on the Ethereum blockchain. Now, this is why that all EVM code now has a larger attack surface. Because now they can also attack your database, and your database has money in it, which is you can see it as like, as I come from a web developer thing, you have MVC, and then you have MVVMMC. So then you add another M and a V somewhere, or at least an M, and then like a C, where C is like your code, and then M is like the blockchain model, which is extremely confusing, and but I can talk to you later about that. And why you use Solidity is it's the most popular and well-developed EVM language. So Solidity compiles itself to EVM bytecode. and all of the nodes trust that they will run that EVM bytecode. And it's funny is, what is the hello world of Solidity? It's to make your own token. It's not a joke. That's why you see a lot of these ICOs doing stuff. Well, they only usually have like WordPress installations, and then they take your money on an address. So not everybody does that kind of effort. So let's go through a small walkthrough. Of my code. So I did all this code in views because, well, why not? I mean, and sort of loading. Anyways, I think that's about it. To skip the walkthrough, I think we went through a lot of code already, so. We're looking for alpha testers for the coin sailor. Contact me afterwards for more information. Any questions? The project you can find here, and I posted the slides to the meetup group. So.
One question here, Josh. Can you talk more about the advantages of the scripting that you mentioned with Ethereum and maybe how that differs from other cryptocurrencies?
A lot of other cryptocurrencies don't implement smart contract language, or if they do, they actually implement EVM. The ones that aren't as well developed because Ethereum has been around much longer. But really why you use Solidity is that it has a lot more tooling, but even the tooling is an issue. Like, for example, when I try to compute 22/7 in Solidity, my division code is actually 10 lines because there's no floating point number system. Now, what I mean by that is it has documentations on float, but it's not implemented in the language because it's 0.4. Mainly because you're dealing with decimal number types. Everything in Ethereum is an UNT, I believe, 256. And they don't really need floating points. Instead, they just go back. And if you go to the first slide, we have, there's no floating point here. What I'm doing is I'm actually doing the division in a large decimal number and then assigning the point.
What do people actually use it for? I can't imagine calculating pi is popular.
Well, there's CryptoKitties where it's sort of a Digimon-like system. A lot of people used it for a DAO, like distributed autonomous organization, but then that failed due to security concerns because it wasn't really in the language. And third, a lot of people use it to defraud people by making ICOs. You have to really be careful on which ICO. If it's advertised by John McAfee, don't buy it, because one of my friends actually bought that. So a lot of the ICOs, you really have to read up on the white paper. And our matching will try to avoid those situations. Ethereum virtual machine.
What's something every developer should know about Ethereum?
That you have to have a very good security mindset before you start coding in it, or just steal other people's code. Like, a lot of the things you may want to do in Ethereum, there's probably already online. It's probably an ERC that you can just go on the Open Zeppelin and look at that Solidity code. But once you actually start to write real code on Ethereum blockchain, you have the DAO, which was for the first system, the distributed autonomous organization, got hacked. because they didn't either audit properly or they didn't have enough tooling to actually see the flaws. I just saw a Y Combinator post today which lists, which is like an OWASP of 10 of the biggest security flaws you can see. And Solidity is not just the only language that compiles to it. There's Python-like systems, but they're not as well developed.
Is there any way I can take Python code and compile it into EVM?
So, sort of. You can't take Python 2x or 3x, cut and paste it into a new compiler, and then compile it. Mainly because a lot of this EVM bytecode costs you money to deploy, like in gas. So if you took your regular Python 2x or 3x, compiled it, and just put it on the blockchain, you probably wouldn't have enough money to do it unless you were like Mark Zuckerberg. You actually want to see that your EVM bytecode, you want as tight as possible, like maybe a microcontroller, or like think of it as, because it's probably the most expensive deployment you can ever do.
Could you elaborate on deployment?
Let me go up. I think I have a local copy of the code. So you have to do two things. You can use the Truffle compiler and deployer, where it's an NPM package, I'm sorry, but you install Truffle, and then there's two commands, compile and migrate. So what you do is, you take this Solidity file, and then run it through the compiler. So here's a Solidity. Here's like a Solidity code. You basically take this code and start your Ethereum client, and then you have to sync it and so forth. And you compile it to EVM, and then you deploy. So there's a Truffle compile and a Truffle deploy. I didn't have this set up. So what that means is once you deploy, you now are on, your code is now on the blockchain, and then you can, that's the expensive way to do it. If you use test RPC, you can compile and then load it just on your local machine, and it won't be on the regular blockchain, it'll be on a test net that you have there. So you should first test it on the test RPC and then deploy it. Any other questions?
So for developers who are looking into getting into EVM development and do not have enough background on the concepts that are required, how would you say go about it? Like getting the lay of the land and getting into building apps on EVM?
So I would say go to the ethereum.org page and look through the sample contracts. Also, maybe take the Hyperledger course by edX, which gives a good overview about the core concepts of what to do. So like here is like the Ethereum system, and then you have to do, so I know it's really small, but this is like not the test network, but this is the real deployment where we have an amount of Ethereum that you want to use. You have the source code. It's translated to the bytecode, which I mentioned. This is a basic contract source code. You can also cut it. What a lot of people may do is there's a contract bytecode, and then you have to have a fee. So as you can see here, there's an amount and there's a fee and a total. So to deploy this 8-line code to the real network at this fee, it tells you this much amount of ether, and it even tells you how long it'll take, and it gives you build a token is the hello world basically. So Think you can, no, you can. So yeah, that's how much Ether I have on this hot wallet.
So how much did that calculation of pi cost you?
It cost me nothing because I did it on the test network. Like non-meaningful calculations can be just done on the test network for testing. You don't want to. You don't want to do like that.
So like, why would anyone want to deploy it if it's going to cost you money? Like, why do you do it? Why do you deploy it onto it?
Because it can, even if it costs you money, it also can have operations that read and write from the ledger, which may increase the amount of money you have. So it's not just a fixed cost and so forth. You actually have other operations like reading, like writing, like for example, in the token example, you can actually sell tokens. So, and if you made those tokens, you can sell it for other Ethereum. Other people will give you Ethereum to buy your token, and then when that code is executed, you will gain money in that way. So, when I said it's read-write, it's not just costing money, a fixed cost. You also can get Ethereum from the code you deploy.
So you make a token and then you sell it. Why would somebody buy it?
That depends on the token. So it really depends. It's sort of like saying like, why would you? Yeah, it depends. You have to define something to do with the token, or you give the token value. Like so, like a Filecoin, like it gives you a DNS like address, or like CryptoKitties. They have like a system that allows you to get another cat. Well, that's like a token where you pay money for the token, then you get access to the CryptoKitty. So, and it really depends on how the token is, it's why the token exists. Like, there's pitch ventures, which if you buy their tokens, they'll give you a way to pitch for real investors.
Okay, maybe we can continue the discussion after.
Yeah.
You'll be around. But thank you very much.